At a subatomic level, matter appears as a chaotic blur of movement. Whether it's the gold in a ring or the oxygen in your lungs, every element is built from the same three components: protons, neutrons, and electrons. Identifying these elements in a lab starts with raw data, lists of particle counts and chemical symbols that record the state of an atom at a specific moment. Imagine a locked steel box. We can see every individual particle inside, but the name of the element remains hidden. To identify what is in the box, we have to look at how these particles are distributed, starting with two specific numbers. The first number is the atomic number. This is the count of protons found within the nucleus. If we count 11 protons in this nucleus, the atomic number is 11. On the periodic table, 11 is the specific address for sodium. No other element has 11 protons. And in neutral state, the atom balances its electrical charge by holding 11 negative electrons in orbit to match the 11 positive protons. This proton count is the foundation of the atom's identity. Even if the number of other particles changes, the element remains the same. Beyond the name of the element, we can look deeper into the center of the nucleus to find the atom's physical weight. This weight is determined by the nucleons, the total count of protons and neutrons packed together. This version of hydrogen, for example, contains one proton and one neutron bound together. Adding these together gives us a mass number of 2. While the proton count defines the element, two atoms of the same element can have different mass numbers. These are isotopes. The number of neutrons in the nucleus can fluctuate, changing the weight of the atom without changing which element it is. Protons tell us what the atom is. The mass number tells us how heavy it is. We find the final piece of the atom's profile by looking for a breakdown in its electrical symmetry. Take an atom with 16 protons and 18 electrons. Because there isn't a one-to-one match, the charge is out of balance. With 2 extra electrons, this becomes a negative ion. If the protons were in the majority, it would be a positive ion. While the nucleus is the permanent anchor of the atom, these electrons dictate its charge and how it reacts with other matter. Now we can solve the mystery from the locked box. The data shows 8 protons, 8 neutrons, and 10 electrons. We start with the 8 protons. On the periodic table, an atomic number of 8 corresponds to oxygen. Adding the 8 protons and 8 neutrons together gives us the mass number, 16. Finally, comparing the 8 positive protons to the 10 negative electrons reveals an imbalance. This is a negative oxygen ion. The subatomic world is organized by these repeatable mathematical ratios. Once you know how to read them, the identity of any atom is clearly visible. If you enjoyed this video, like, share, and subscribe to Science Knowledge for more easy-to-understand chemistry and science lessons.